Unlike derivatives, integrals can actually be very difficult to find. You're going to learn later on in this class that there's actually many types of equations where we cannot find the antiderivative. And it's amazing that that does exist, but that's when we have to start using modeling techniques and things like that. So a lot of the rest of this class is, we're going to learn how to apply integration, but we also have to spend a lot of time learning how to, figure out what is the antiderivative of a function. And so we come up with a bunch of rules that we had in a previous video, but we also come up with a number of techniques for integrating. And so in this video, we're going to go over the first technique, and this is probably going to be one of the more important ones. Always remember this technique because it works in so many cases. And the first technique for integration is to rewrite before integrating. Rewrite before integrating. It is pretty amazing how often something that you can't integrate can really be simplified by just rewriting it, and voila, you can integrate it. So something to kind of keep in mind. So always keep this one in the back of your brain as something that you might want to try first. So let's look at some examples. So let's say we have the integral of 1 over x to the 7th power. And, dx, sorry. And so, our job is to, figure out, well, what function, when I take the derivative of that, gives me 1 over x to the 7th. Now, I'm sure many of you could probably just kind of look at it and think about it and go through a couple of iterations in your brain and figure out what it is. It's not that challenging. However, that does take some time, and we do want to try to figure out how to integrate these things a little bit quicker. So what we do is rewrite sorry about that, rewrite before we integrate. And so what we're going to do is look at this. We're going to take the integral, and notice that 1 over x to the 7th is the same as x to the negative 7th. Now all of a sudden I look at that and think, oh wait, now that's just a basic power rule. And so the power rule says, well, we add 1. So when we add 1 to negative 7, we get negative 6. So we have x to the negative 6, and then we divide by that number, negative 6 plus c. And then we can rewrite it again, so we don't have the negative exponent. So we're going to have a negative 1 over 6x to the 6th plus c. And there is our final antiderivative. So like I said over here, some of you might have been able to just sit there and think about, oh, what is the derivative that gives me 1 over x to the 7th? And you could have gotten it. But notice how rewriting creates a much simpler integrand, or something to find the integral of, and we were able to solve it a lot quicker. Let's try another example. Let's say we want the integral of the cube root of x. Okay, now we're definitely looking at something where that's going to be pretty tough to look at it and figure out, what is the derivative, or what function, when I take the derivative, gives me x cubed? I don't know if I would come up with that one. So let's rewrite, and we end up with, okay, remember, if you have a cube root, we can rewrite it to be a rational exponent. So we would have x to the 1/3 power. Now I can use the power rule. So I add 1. So let's see, 1/3 plus 1 is 4/3. And we divide by that number plus c. So we end up with 3x to the 4/3 over 4 plus c. And there is our solution. That should be 4/3. So again, this is an extremely powerful technique, and it works well. Let's try one more. Let's say we want to take the integral of t squared plus t to the 4th all over t, just t, there we go, dt. Okay, now we're definitely getting to a point where, gosh, trying to think of a function where the derivative equals that's pretty challenging. That would take a lot of going back and forth and probably a lot of getting the wrong original function. So when you have this situation, you definitely want to rewrite. And it's actually a pretty simple deal. I mean, all we have to do is rewrite this to be the integral of t squared over t plus t to the 4th over t, so we can separate that into two fractions. And so then we're going to get the integral, well, t squared over t is just t, and t to the 4th over t is t cubed. And so notice that with a basic rewriting, we were able to take this integral this function that we definitely were not going to come up with an integral of, and turn it into two power rules that are easy enough. Okay, so remember we add one. So when we have t, it's going to be t squared over 2 plus t to the 4th over 4 plus c, and easy enough, we have our antiderivative. Okay, so we're going to learn a number of techniques for integrating. Some of them are going to be pretty simple, some of them, a little bit more involved. But this, I feel, is one of the most powerful ones. Just the simple concept of taking whatever you have, rewriting it, and turning it into a simpler equation, it really does help out, and it does solve a good number of integrals and finding antiderivatives.